Hey, welcome back. We are starting with Unit 7 today for on-level pre-calculus. This unit talks about inverse trig functions. As I said, notice here, inverse trig functions. We have previously learned about trig functions and how to evaluate their values using the unit circle here, our fantastic unit circle. Now we're doing inverse of trig functions, and clearly, as it states, this builds upon what we learned previously in Unit 6. So I'll try my best to review real quickly what we learned before we talk about their inverses. By the way, topics we'll cover in this video are going to be graphs of inverse trig functions and two, finding the exact value of inverse trig functions. Before we move on, again, let's do some examples of what we've learned previously. If I were to ask you, hey, what is the value of sine of pi over 4 and what's the exact value of sine pi over 4? Well, we'll go to pi over 4 and the sine values are the ones that are listed in red here, or the y component. And we will get our sine value. We're going to say it's root 2 over 2 and not the decimal value for it because that is not going to be the exact value. Another example, if I were to ask, hey, what is cosine of 240 degrees? Well, you'll end up going to 240 degrees, and the cosine value there is negative half, because cosine is the x component. And one more, tangent was another one that we talked about. Tangent 5 pi over 6, let's say, they'll go to 5 pi over 6, and the tangent value there is the one on the very outside, negative root 3 over 3. Talking about negative functions, if I were to ask you, hey, what's sine of negative pi over 4? Now with the negatives, you'll go to positive first. So sine pi over 4 is this one. And you're going to go ahead and reflect it. That's the middle point. So we'll directly reflect it across x-axis. If this angle represents pi over 4, then going the other way around will represent negative pi over 4. Now once you determine that we're talking about this angle right here, once we get the location, then all we need is the sine value at that point, which is negative root 2 over 2. Similarly, if this question was cosine of negative 240 degrees, then we will end up going to 240 first and then reflect over. Let's do it. 240 degrees right here, which is this point, so that reflected directly over would represent this point, and cosine value there is negative half also. So if you notice, cosine of 240 and cosine of negative 240 have the same answers because they're the x values, and x values are the same in the second and third quadrant, hence we ended up with the same answer. So this is finding the exact value of trig functions. Because we are doing inverses, it was very important for me to show you that, because let's say I bring this back here, cosine 240 degrees is negative half. This represents the input, obviously, and this is the output of the function, x and y. Inverse is when input and output are swapped, which means when y becomes the input and x is the output, we automatically have the inverse of the function. Inverses are written with that negative 1 sign on top. So cosine inverse would automatically mean where y becomes the input and x turns out to be the output. And this is the format of inverse functions. So if I were to write this function as an inverse question, I would write cosine inverse negative half, and I'm looking for an answer, which means for what value, for what angle does the cosine equal negative half? And the answer here will be 240 degrees, where x and y swap signs. However, I'm pretty quickly going to tell you that cosine inverse has restrictions. So this answer will not be directly acceptable, and it will have some restrictions, but we will talk about that in a bit here. As of now, please just recall that inverse functions are the ones where the input-output are swapped. Here's another example. This was example 1. Example 2. If, let's say, tangent of pi over 3, let's say what's the value of that? Pi over 3 tangent value, root 3. If I were to write this as an inverse question, tangent inverse, root 3 would equal, the answer would be pi over 3. Another example, let's say sine of 60 degrees is equal to root 3 over 2. And the inverse way of writing that would be sine inverse root 3 over 2 is equal to 60 degrees. In this case, this becomes a question, and we are trying to find the angle or the output here, which used to be the inverse for the regular function. So this is the basis of it. If I were to now talk about the graphs of inverse functions, graphs of inverse of cosine, sine, and tangent, it will take us a few minutes to describe that. So let's talk about sine inverse graphs first. But again, to be able to get the inverse of sine function, I need to first know what sine graph was, which is what we did in the last unit. Sine, if you remember, looks like this. Goes up halfway through and then goes down the other half. And we also learned that one revolution is 2 pi. So the cycle or period of sine function is 2 pi. If this is 2 pi, halfway through would be pi. Half of that would be pi over 2. And 3/4 would be right here. If you also recall, this represents the first quadrant. This is the second quadrant, third quadrant, and fourth quadrant. This is Q1, Q2, Q3, and Q4. And after that, it starts to repeat itself. So on the other side, if I were to go here, and it goes on forever in both directions. This is what the basic sine function was, which makes us think that what is the inverse graph of sine function? Also, let's make it clear here that the domain of our sine function used to be all real numbers. In other words, negative infinity to infinity, because it goes in both directions forever, left and right. Range, on the other hand, had restrictions because the highest point was 1 and the lowest point was negative 1. So y is restricted between 1 and negative 1, where both negative 1 and 1 are inclusive. So this is our sine graph. Y equals sine x. So if y equals sine x, how would I write the inverse of that? Inverse would automatically be sine inverse, but then what will follow next? The output, y, will become input. So I will swap x and y roles, and this is what the sine inverse equation would be. This could also be on your math Excel, so please watch out. Make the connection between the sine function equation and the sine inverse equation. Now that we have the equations, let's draw the inverse graph. So I'm going to again draw the sine cycle first. Make it color-coded. Let's call this the sine graph. I have to put a little bit thought into it before I do it. That's why I'm being careful here. Right here, right? Now inverse functions are symmetric with respect to y equals x line, which we also covered previously. So here's the y equals x line. Now, if I were to, again, tilt your head towards this line, slightly to the right, to be able to construct a graph that is symmetric with respect to that line. If I were to do that, I would draw something like this, if that makes sense. And I did my best. I think it's not the best one here, but let me try it again. and right there. You see that how the blue and the green are symmetric about that red line, which is y equals x line? That's what it would be. But if you think slightly more about it, what happens here is that the green one is not really a function because it fails the vertical line test. We have 2 points where the line crosses vertically, so it fails the vertical line test. And hence, to be able to take care of that, we do not do the inverse of the blue part of it. To make it a function, and I'm going to literally trace it back here. To make it a function, we only focus on this part of sine graph. The first quarter, this one, and this one. We only restrict ourselves to the highest point here, which represents pi over 2, to this point here, which represents negative pi over 2. If we restrict it and then we draw the inverse, and again with inverse, now I'm trying to again make a reflected image of the green part of the graph with respect to the red line. And there. And if you again tilt your head slightly to the right along this line, y equals x, you can see how the green with the original sine graph and the peach one, they are symmetric with respect to this line. So there are restrictions we are following here, and that kind of makes the sign a little more complicated than the normal one, the regular sine function. With this one, I'm going to write this again, sine inverse x equals y. The input x, where x is restricted between sorry, there was a pause there. If I were to label this point is pi over 2 comma 1 because that's the highest point. And if I were to label this point this one right here would be represented as negative pi over 2 comma 1. Now with the inverses, because the input output swap roles, this point right here is going to become 1 comma pi over 2, the x and y swap roles, and this point on the inverse will be reflected of negative pi over 2, negative 1, which will become negative 1 comma negative pi over 2. So now if I were to follow the restrictions here, x is restricted between 1 and negative 1, and y is restricted between negative pi over 2 and pi over 2. These restrictions are very interesting, the domain and range. Also notice how the range here was between negative 1 and 1, but now here the domain is between negative 1 and 1. And with inverses, domain and range also flip roles. Whatever the domain of the original function is, that turns into the range, and range turns into the domain usually. However, because our range and domain are both restricted now, because in this case, our domain is restricted to between pi over 2, negative pi over 2 and pi over 2, and our range is restricted between highest point being 1 and negative 1, negative 1 and 1, both inclusive, and I should put this brackets here as well. With the inverse, both have swapped their roles. And this is what the inverse of sine looks like. Similarly, if I were to show you cosine, a regular cosine x equals y, just as an example, cosine 45, let's say, equals root 2 over 2. So 45 is the input, root 2 over 2 is the output. If I were to make it a cosine inverse function, then x and y will swap roles, and it'll look like this. That's the equation wise. Graphically, and again, it becomes a little challenging to show it, but that's why please bear with me. If you recall, what did cosine look like? Cosine was, I used to tell you, think of a champagne glass. That's what cosine looks like, starting right off of y-axis at the highest point 1, goes all the way to the lowest point here, reaches minimum point, and back to the highest point. And this was one cycle for it, which means this is 2 pi, this part is pi, That's pi over 2, and this part is 3 pi over 2. So if I were to draw inverse of this, basically, I'm going to draw this mirrored line, and I will have to inverse this. And again, because of domain restrictions, the inverse is not going to be a function if I were to just draw an inverse of that. So what we will do is, to take care of it, we will consider only certain section of the cosine graph, which is, in this case, is going to be from 0 to pi, just this part. Only considering that. So I'm going to try and erase the rest of it. There it goes. Erase the rest of it here. Now we are only considering this part of cosine, which is between 0 and pi. Excuse me. If I were to not draw the inverse of this, which can again be a little challenging, let's get the points here. This point is represented by 0, 1. This point is represented by pi, -1, right? So on the inverse, we will have swapped roles. 1, that. Let's change color here. Be patient, because I have to, again, tilt my head towards this line and draw inverse of that. So if I were to just draw inverse of this part of the pink, this is going to look like this, right? And if I were to draw inverse of this part of this pink, I would go on the other side. Yeah, there we go. What would be this point here? This would swap positions. As I said, it's going to be 1, 0. And this one is going to be swapped version of this, which is going to be -1, pi. And again, domain range will swap their positions. And the pink one, which is the original cosine function, domain is restricted between 0 and pi. That's the domain. And range is restricted between -1 and 1. This is for cosine function, but for cosine inverse, swap their rules. Domain is now 1 to -1, and range is 0 to pi. This will be the case of cosine inverse. And this means more than just what it looks like. This automatically also means the first and the second quadrant. And this, for sine function, automatically means the first and the fourth quadrant. So if all this seemed confusing, what you can remember is the restrictions for sine inverse, cosine inverse, and tangent inverse. See if you can remember this part. Sine inverse, the answers are restricted in quadrant 1 and quadrant 4 only. You can only have answers in these two quadrants for sine inverse. Remember, that is not the case for sine. That is not the case for sine. For cosine inverse, the restrictions are first and second quadrant only. The answers can only be in those two quadrants. And for tangent, I know I did not graph tangent, but trust me, the tangent graphs are restricted just like the sine graph. They're restricted between first and fourth quadrant only. So if the above was confusing, this is the gist of whatever I went over previously. The graph of sine and its inverse. But if you notice how the sine graph looks different, because like we do not take the entire sine graph, because the inverse of it ends up not being a function. So for both of them to be functions, we restrict the sine. And I'm going to erase this part, all of that. We restrict the sine only to the first quarter here and the quarter right before 0, because that's a 0. That automatically restricts us to, this was quadrant 1, and this turns out to be quadrant 4, if that made sense. If not, just remember sine is restricted between quadrant 1 and 4, cosine between 1 and 2, tangent between 1 and 4 also. Now we will switch on to topic 2, which is all going to be based off of this bubble and the restrictions. What is topic 2 and the last topic? Finding the exact value of inverse trig. Inverse trig. And we can make up a lot of such questions. Let me start with something simple. Again, when I reminded you here earlier, if I were to ask you, hey, what's sine of 45 degrees? You're going to go to 45 and get the sine value from there on your unit circle. 45, sine value, root 2 over 2. What if the question says sine root 2 over 2, sine inverse of root 2 over 2, then it's a backwards question. It's asking you, for what angle does sine equal root 2 over 2? So when you will try and find this answer on the unit circle, you will notice, first of all, you will look for root 2 over 2 as a sine value, and you will notice there are two answers every time. But there are restrictions to sine inverse that we just talked about. Sine is restricted only to quadrant 1 and 4. So this answer, the 135 degree or 3 pi over 4, will be the answers that will be ignored. We will only consider pi over 4 or 45 as our answers because of the restrictions, and there was none in fourth quadrant, so we're not going to pick anything from there. So we will say the answer here is 45 degrees or pi over 4, depending on how they want the answer. If they want it in radians, we have pi over 4. If the answer is wanted in degrees, we have 45, but we're not going to consider the other as an answer. I'm going to insert this one again, move it down. Okay. Oops. Let's see if I can further scoot it down. Sorry about that. Let's just scoot it to the next page. Okay, let's say we have something like this, where the question says cosine inverse of negative root 3 over 2. Again, remember, look at this carefully and tell yourself, is this a cosine question or is it an inverse question? Well, it's asking you for the inverse of cosine, which means they're asking me to find the angle where the cosine value equals negative 3 over root 2. So you'll look backwards and you'll go, where do I see negative root 3 over 2 as the cosine value? I see it here, and then I also see it here. There are two of them. So which angle is the answer? 5 pi over 6 or 7 pi over 6? Well, that's when the restrictions come into play. And again, cosine inverse is restricted to quadrant 1 and 2 only. So you would say, wait a second, I will have to ignore the 7 pi over 6 because that's not in quadrant 1 and 2, and the only answer is 5 pi over 6 if asked in radians, or 150 degrees if asked in degrees. Here's another example. Let's look at tangent maybe. Tangent inverse of negative 1. Find negative 1 as tangent value. And again, if you notice, there are two of them. Which one is the right one? Tangent is restricted in the first and fourth quadrant only. So you'll have to ignore this and you'll have to pick this one, and that is 7 pi over 4. So these answers go by really quick. You just need to know what you're doing and the restrictions. I can give you several such examples. Let's say we have that. Okay, tangent inverse negative root 3. And what angle corresponds to that? There's one here. There's one tangent value right there. But again, these two are not acceptable for tangent inverse, and hence the answer is 5 pi over 3. Okay, some more examples. Okay, cosine negative root 3, negative root 2 over 2. So look for cosine value, which is x values as negative root 2 over 2. I see one here, and I see one here. But cosine is only acceptable in the first two quadrants, so this will have to be ignored, and we will get this as an answer, 3 pi over 4. Let's say we have sine half. Okay, find sine value half. Sine is the y coordinate. I see y half here, and I see half there. Sine is only acceptable in the first and fourth quadrant, so we'll have to ignore that. And the answer would be 30 degrees, or pi over 6. This is called finding exact value of the inverse trig functions. Sometimes you will notice that in Math Excel, these probably won't be accepted as the right answer. So let me do some of these, which the ones that are not acceptable. And how do I know that? So I'll tell you that here. One more time, we're finding tangent inverse of -1, which means the angle where tangent value equals -1. And if you were to go find for -1, there's one here, and then there's one here. Remember, you got that part, I think. With tangent restrictions being quadrant 1 and 4 only, this is not going to be acceptable. So we're going to accept this, right? 7 pi over 4, like I said earlier. Now watch what happens. Because this is in the fourth quadrant, angle 7 pi over 4 is this one, right? And then this is the stationed hand. When doing negative, or when going in the fourth quadrant, 7 pi over 4 is actually representative of going counterclockwise because it's a positive angle. So this represents 7 pi over 4. However, since we are not going to the second and third quadrant, it's better to write this angle as a negative angle going this way, which will be a faster way. So this may not be acceptable in Math Excel. Be very careful. How would I write this angle instead? Well, this is the middle one here, and as I've taught you in class, the middle one here, you can simply just reflect it over and call this angle negative pi over 4 instead. Same thing. We end up with at the same location. However, going this way would be calling this angle as a positive angle, and going this way would be calling that same angle as a negative angle, but that's a reference angle. And this would be acceptable. If the same question was asked in degrees instead of radians, I'll show you that as well because it looks easier in degrees. So we're still finding -1 for tangent value, and this is it. We're going to ignore that because that's in the second quadrant. So how do I construct that angle? It's this one. And that is the initial hand, and that's the terminal hand. What is this angle representative of? This is the center one. So center represents 45-degree angle here. If I were doing a negative of the same thing, it would just be a negative 45-degree angle here. So both of these are correct answers. It just depends on if they're asking in radians or degrees. Let's do another one, this one, and check if our answer was correct or not. Tangent inverse of negative root 3. Let's go find negative root 3 tangent value. It's right there. And right there. So tangent, if you notice, you always see the same answers across. With sines, you will notice if you find something here in the first quadrant, you will see the exact same answer across from x-axis. And with cosine, you'll notice there's a root 2 over 2 here. sorry, that was cosine. I'm sorry. This was cosine, and you will notice it across x-axis. And for y coordinates, or for sine values, you will notice this exact same answer across from y-axis, reflection of y-axis. Since it was tangent, once I found one of the tangent values, I knew the other one is directly across from it, on the diagonally opposite, symmetric with respect to the origin. So anyway, but I'm going to ignore this answer, right? Because the restrictions with tangent are first and fourth quadrant only. So I'm like, okay, the answer should be this reference angle, 5 pi over 3. But wait a second, again, I'm in the fourth quadrant. So instead of going 5 pi over 3 as a positive angle, this will be acceptable as a negative angle. And all you have to do is get to the reflection angle. Since this is pi over 3, the negative way to represent this angle would be negative pi over 3. So this will not be acceptable. So there are two things that you have to look at. Number one, am I in the right quadrant? Am I following the restrictions of the inverse trig functions, the sine, cosine, and tangent? Number one. And number two, am I writing the answer correctly? If you're in the fourth quadrant, we will have to write the angle as a negative angle instead. So I hope that made some sense. It is new. It does take some time to kind of evaluate and understand what's going on. What did we do basically? In the very beginning, I kind of reviewed about this basic cosine by sine wave, the sine trig function, and we were trying to graph the inverse of it, but with the inverses, we have some restrictions on domain and range because we want to still keep it as a function, and hence the restrictions for the sine turn out to be this part of the sine curve. One in the first quadrant and the other one in the fourth quadrant. And we restrict our sine to this. Once we make that restriction, the inverse also turns out to be a function. Same thing with the cosine. We just restrict the cosine, this pink value here, from 0 to pi. And once we draw the inverse of that function, that also turns out to be a function. And the pink and the blue ones are inverses. We did not do tangent. For tangent, I just told you the restrictions. 1 and 4, and 1 and 4 for sine. Cosine is the only one that stands out. Keeping that in mind is how we evaluate the exact value of the trig functions. Not every answer is acceptable, just the way it is. So we have to kind of think about the restrictions and the correct way of writing angles. That is it for this little lesson. I shall see you in the next video with the next unit.